Okay, we're back. We had a really long break, and now we're going to solve questions. Because my mock's tomorrow, and I still have a lot of things to practice. We're in graphs of functions. We solved this one before. We have solved this one before I left. I did some mistakes. I don't even remember my mistakes, but I did some mistakes, and I looked at them before I left, and I just said I had to focus more. I'm gonna go get my glasses because I'm not wearing my glasses right now, and come back.
Hello. Hello.
Okay. We let's look for more, like a bigger mark question. We're all okay. This one's 5 marks, so let's do part A and B. Okay, got paper. Sketch the graph of this showing the coordinates of any turning point. I don't know how to find turning points. I only know how to find them using the first derivative. You're not asked for axis-intercepts, so you didn't need to find the y-intercept. For the turning point, when a quadratic equation is in this form, the turning point is QR. Okay, no, I read this before. Okay, so it's 2, -3. No. Okay. I would have just done the first derivative, so that's way too many steps though. The sketch shows part of a graph which has this equation. Find the values of A, B, and C. What? Oh, okay. And it gave me the intercepts, the y-intercept, and the x-intercepts. So the C is 12. Okay, so you have the two values for x, -1 and -3, and you know that y equals 0. And you want to find a and b, so you want to find a and b that, and you have c is 12. You want to find a and b that give you all of these conditions as true, satisfy all these conditions. So 0 equals a, and then let's try -1 first, squared, which is 1, so it equals a, okay, 0 equals a minus b plus 12. So a minus b equals -12. Wait, no, let's keep it in the 0 form. And then you're going to do the same with -3. So 9a minus again because it's negative 3b plus 12 equals 0. Yeah. Okay, and then now you know that a minus b plus 12 equals 9a minus 3b plus 12. Cancel out the 12s. Add, okay. Subtract, okay. I think I should have found a and then substituted it into the equation instead of this. So I'm going to do that now. Using the first equation, a is 12 plus b. And then using the second equation, put a in, put 12 plus b instead of 9. And that's going to be, okay, so 9 times 12 is 108 plus 9b minus 3b plus 12 equals 0. Now find b. So 6b equals negative 120. B equals negative 20. So it's actually minus 20.
وريني بتعملي ايه؟
بذاكر.
وريني ازاي؟
شوفيها على اليوتيوب.
انت بقالك كام ساعة بتعملي ايه؟
5 دقايق.
قبل ال5 دقايق.
لسه قاعدة من 10
ما
دقايق.
كنت بتعملي قبل كده؟
كنت قاعدة بره. الياس اللي كان قاعد.
يعني؟
لا، الياس اللي كان قاعد.
كنت قاعدة بره بتعملي ايه؟
ما بعملش حاجة.
ليه بقى؟ ليه مش ماسكة حاجة بتذاكري فيها؟
انت بتهزقيني على اللايف ستريم، يعني حابك دلوقتي.
ما انا عمالة ابص لك عشان تاخدي اكشن، انت مش هتاخدي اكشن.
حاضر. You found B, so I'm gonna find A. It's 12 plus B, so it's 12 minus 20. That's -8. So A equals -8. Okay. Oh, that's not what I got. Okay, let's go back. It's really close to what I got. Okay, let's try this again. C is 12. That's like straight up. I don't need to work for that. And then I have ax squared plus bx plus 12 equals y. And I know that when y is 0, so a x squared, which is 1, negative 1 squared is 1, and that's 1a. And then negative x, so minus b, plus 12 equals 0. And then when I substitute 3 into it, 3 squared is 9. So that's 9a minus 3b. Okay, I didn't understand what I did wrong. Plus 12 equals 0. Okay. So a equals, negative 12. Negative 12. So b minus 12. Okay, there's my mistake. B minus 12. And so when I do that, it becomes 9b minus 108 minus 3b plus 12 equals 0. 108 minus 12 is 96 equals 6b divided by 6. That is b equals 16. There we go. Okay. And then a is 16 minus 12. A is 4. A equals 4. Okay, I found my mistake. And so A is 4, B is 16, and C is 12. This is 5 marks. First mark is for... What was that? I didn't do that. The root from the quadratic equation of this such that that's not what I wrote. Oh well, that's okay. Why did I do this wrong? Oh, okay, so I have to remember that when it is in the form a x minus b plus c, the midpoint is bc. The turning point is bc. Okay, so note it to self. I'll come back to that later. Do these have multiple parts? This is 5 marks. It's not 2 marks. So let's do these. The graph is shown. Use the graph to solve this. I have to increase so I can read it. That's 3 and negative 3. But they didn't... okay. That's 3 and negative 3. That's not... It's okay. It's 1.5 and negative 3. I can't focus. Hold up. Paper. This equation can be solved by finding the intersection of the graph y equals 2x squared plus 3x minus 9 and this line. Find the value of a and b. See, I need help with this. I don't know what this is. So if you add them together, they'd give you this. No. If you subtract them from each other, they give you this. So this is 2x negative 5. Okay, I get that. Okay. Let's try something else. Estimating Gradients, very hard. Very, very hard. The velocity time graph shows the first 40 seconds of a car in a race. Work out the average acceleration for the first 40 seconds. Give the units of your answer. Work out the average acceleration for the first 40 seconds. Give the units of your answer. Okay. It's 27 over 40 meter per second squared, isn't it? 0.675. Oh my god, meter per second squared. Okay. Estimate the time during the 40 seconds when the instantaneous acceleration equals the average acceleration. You must show your working on the graph. I'd put my ruler on it and then I'd move it until it was, I'd say like 10 seconds, probably. Maybe a little under 10. It's a little more. Since more tangent drawn, you must draw both lines. Okay, two points have equal acceleration where their tangents are parallel to each other. Instantaneous acceleration is equal to average acceleration where the tangent to the curve is parallel to the line. You must draw both lines on the graph to show this. Okay. I was like close considering I did not draw. Wait, if I try to draw, what happens? Where's my ruler? I'll just draw with my pencil book. Yeah, okay, it is 12. Okay. I'll go to a different one. The graph gives information about the variation in the temperature of an amount of water that is left to cool from 80 degrees Celsius. We get an estimate for the rate of decrease of temperature at 300 seconds. Draw a tangent. You have to draw a tangent. I have to print these out. Hold on, let me print them out. All tangents. Ingredients. Here it is. I need very hard questions. So it's 6 very hard questions. I'm printing. Where do they start, the very hard questions? Oh, there we go. Page 27. Pages. Custom 27 to, how many is it? 38? 39? Okay, it's out of bound. 38. Very hard questions. Oh, there's a blank page over here. One. You know what? I'm just gonna. I will print them. Print. Okay, it's supposed to stop too. I'll just do something else till we get to that. Real life graphs. Here is a speed time graph for a car journey. The journey took 100 seconds. The car traveled this many in the 100 seconds. Work out the value for V. What's V? Velocity. Average speed. I'm just gonna. Oh, is it drawn on the diagram? That's not. Oh, there it is. I found it. Okay. Okay, 100. This is in meters, so I'm just gonna convert 1.75 kilometers into meters. And that's 1, 2, 3. So it's 1750 meters. Now this is equal. Base times height, right? And then, okay, so it's equal to 40. My brain. 40 V plus half of 20 V plus half of 40 V. Okay, and so it's 40 V plus 10 V plus 20 V. So it's equal to 70 V. So 1750 divided by 70 equals V equals 25. Okay. Yay, it's 25. They used the trapezium. I did not. I think it's fine. I got the right answer in the end. This is a hard question, supposedly. Describe the acceleration of the car for each part of the journey. Acceleration is constant, 0, and then constant, but it's negative. First part, constant and positive, 0, and the third part is constant and negative. Constant acceleration in all parts. 0 acceleration in part 2 is acceptable. Gradient is positive, 0, and negative. Let's say it. I'm not gonna do that, so I'm just gonna keep it as positive, negative, 0. Okay. Oh no, I want Lily. Okay. Lily and Beth. I'll do Lily and Beth. Lily goes on a car journey. Oh, this is graphing. Don't have time. This is also graphing. Don't have time for graphing. Lots of my questions are graphing. Oh, this one's 4 marks. Okay. Izzy runs an 80-meter race in 14 seconds. During the first 6 seconds, her speed increases at a constant rate. During the last 8 seconds, her speed increases at a different constant rate. Her speed at 14 seconds is 2 meters more than her speed at 6 seconds. Here's a sketch of her speed time graph. Work out her acceleration during the last 8 seconds. State the units for your answers. Okay, so in 8 seconds, hold up. I don't know her first speed time. Oh, you just need her acceleration. So it's 2 meter change. It's 2 meter per second change over the 8 seconds. So 0.25 meter per second squared. I think that's pretty fast. 0.25, which is 1/4, 1/4. When Izzy finishes the 80-meter race, her speed is V meters per second. Work out the value of V. V meters per second. And oh wait. No, never mind. Wait. In the last 8 seconds, I didn't know her speed at the beginning. Wait, I do. I can't find it out. 0.25 meters per second squared. She ran. Wait, what am I finding, V? When she finishes, her average speed is 80 divided by 14. Right, which is 5.7. But that was not her last. Wait, what? No, it wasn't. That was her average speed, not her top speed. Okay, let's say, okay, it was V. And then here it's V minus 2. Right. And then here it's 0. And then she spent, how long did she spend? She spent 6 seconds and then 8 seconds. And in total, she ran 80 meters. And here her acceleration was 0.25 meter per second squared. Right. How do I use this? I want her speeds together. Both her speeds. Oh, you use both speeds. O over 2 equals the average speed, I think. She never stopped. Right, so 2v minus 2 equals 5.71. Add 2, and then divide by 2. And you get v equals 3.86. I'm wondering. It's not. Oh. Oh. Okay, I was on the right track when I said v minus 2, but I didn't get past that. Okay, that makes sense. This is her v, and then this is her time, and then we have the area of this, right, which is, okay, so this half of 6v minus 12, which is 3v minus 6, plus 2v minus 2 times 8, 2v minus 2, so it's 3v minus 6, plus 16v minus 16 equals 80. So 80 plus 16 plus 6 divided by 19 gives you 5.36. That's not the right answer. Or did it wrong? Okay, let me draw this on a cleaner sheet of paper. Hold up, what am I doing? This is 0, this is 6, this is 14, so this is 8 and this is 6. This is v, and this is v minus 2. Write this out. This is 6 times v minus 2. And then it's half because it's a triangle. So it's half of 6 v minus 12. It's 3v minus 6. Okay, that's the first part. Plus, is it not 80 meter race? It is 80 meter race. Okay, and then we have 18. Oh, it's half. Okay. There's my mistake. It's 2v minus 2 times 4, not 8. So it's 8v minus 8. And there you go, 80 plus 8 plus 6, 9, 10, 11 divided by 11, you get 8.55. Yeah. I think that's enough for your life graphs. Graphing inequalities. Oh, okay. Oh, I love this. It's easy. Oh, thank God. Given that x and y are integers such that this, find all the possible values of x. Okay. We're going to get the same trick because here it says are integers. And x plus y equals 13. So x equals 13 minus y. 5 minus 13 minus 5. 13 minus 5 is 8. So 8 is a common. Okay, 13 minus 6. I'm just going to check that. It's not 7. So 13 minus 7, 6. 13 minus 5 is 8. Okay. So 6. 13 minus 8 is 5. That's it. It's 6 and 5. Yay! Okay, on the grid, show by shading the region defined by the inequalities. Okay, let's do this real quick, because I'm not going to solve a lot of these questions. Snippet, and then share the snippet. Okay, we have y is negative 1 over here, and it can be equal to, so we're going to draw it, and then greater than or equal to negative 1, so it's the parts on the top, right? And y is less than. Okay, let's draw the lines first. 4 minus x. So x is 0, 4 minus x is negative 4. Oh, that's a lot. 4 minus x. Hold up. 4 minus x is 4. And then 1 is going to be 3. And then, okay. Here we go. Let's draw that. Yeah. And then 3x minus 1. It's okay, 3x minus 1 is 1, so it's 3 minus 1, it's 2. Okay. 2 times 3 is 6, minus 1 is 5. Okay, and you go by 3's. So, hold up. No, it's over here, sorry. That's good enough. Hold up. I'll try to fix it. Let's try that again. Minus 1. Hold up. Okay, and then, yeah. Shouldn't it intercept at negative 1? I think I did something wrong. Because when x is 0, it's negative 1. And when x is 1, it's 2. Yeah, Yeah, I did a mistake. And then this is the area. Yeah. Yeah, that's it. It was black, wasn't it? It's okay. You answer? Yeah, I did the same. Oh no, I did not do that. Wait, did it say shade the unwanted regions? On the given shade, by shading the region defined by the inequalities, mark this region with the letter R. Okay, I need to ask when. Okay, I'll just text my teacher. Where did you go? Yes. When do I shade the unwanted region? And when do I shade the wanted region? Question mark. Well, it didn't work. It's okay. I'll give that to myself because I know. Okay, transformations of graphs. Okay, really hard question. This graph is shown on the grids. On this grid, sketch the graph. What grid? This grid? Yeah, it's the same grid. Okay, so -3 means 3 to the right. And then negative x it was when it was 1, it was -1, and now when it's 1, it's 1. It's -1. So pretty much just flip on the x-axis and then +2, bring it 2 upwards. The flipped version, I think. Okay, flip on the y-axis and then we get 2 up. Ooh, I did not know we were going to flip. The y-axis, give you answer in the form of this. So it's going to be -2 from the outside. And then expand. Why did they just expand? Okay, I need to revise this. So let's screenshot it. I can send it to my mom. Paste. What else do I need to revise? Let's go differentiation real quick. Very hard. Okay, a particle. Oh, damn. I don't know how to do these particle ones. Particle moves along a straight line. The fixed position O lies on this line. The displacement of the particle from O at a time t is t greater than 0 in s meters, where the meters are equal to time. And the velocity of p is v meters per second, where v is greater than -5. Find an expression for t in terms of v. Give you an expression in the form this, where k and m are integers to be found. Right. This is meter. V is meters per second, right? And this is the meters. This another particle. Yeah, I have no idea. Okay, so differentiate s with t to get an equation for velocity. Wait, so that's something I'm supposed to know? Wait, what? It gave me meters equals an equation in seconds. If I want velocity, I just do the first derivative. Okay, in order to solve, so when you have meters equals seconds, you can do the first derivative on the seconds and get the velocity. So v and t into the equation for velocity, rearrange t equals 0. Substitute into quadratic equation. Cancel down. Let's try that. Need blank paper. Need blank paper. Need blank paper. I guess it's gonna work. So we just learned that if s you have meters equals seconds, you can differentiate to find, what do you find? Oh, velocity. So 3t squared plus 8t minus 5. This is your velocity. Make it equal to 0. So, I think it's just, wait, I forgot steps. The velocity of p is v, where v is greater than or equal to -5. This is v. Is this. I want it greater than or equal to -5. And then equal to -5. So add 5, you can start with 5. No, you don't. That's not what they did. I'm going to go to a different one. I solved this at school today. And this one, we had a problem, and so let's try to solve that. Find the value of x where r has its maximum value, and this is a squared thing. So, you're looking for a turning point. That's exactly what you're going to do. So x over 4, my brain hurts, minus 6 minus root 3x. Okay. 200 minus 6x plus root 3. Then x it on. So 200 x minus 6x squared plus root 3x over and then do first derivative of that. Multiply by 4. Hoorah. On the maximum value of 4. Let's do first derivative. Wait a minute. It's just divided by 4. 200. What's 200 divided by 4? It's 50. 50x minus 3 over 2x squared plus root 3 over 4x. So 50 plus root 3 over 4. Root 3 over 4. How am I not finding the first derivative yet? Find the first derivative. By multiplying 3 over 2 by 2, so it's 3x, it's negative 3x plus 200 plus root 3 over 4 equals 0. 3x equals 200 plus root 3 over 4. 200 plus root 3 over 4 times. I did something. I did something wrong, I'm pretty sure. It's just a derivative. Oh, what? I'm gonna get another one. I can't solve this one. Let's get this one. Okay, this one's 5 marks. Point A is the only stationary point on a curve with this equation, where k is a constant, given that the coordinates of A are this. Find the value of A. Differentiate, so it's 2kx plus x to the negative 1. Negative 1 times 16. It's minus 16 over x to the square, right, equals 0. Right. Alright. Multiply by x squared, I think. So it's going to be 2kx cubic minus 16 equals 0. Add 16, divide by 2, kx cubic equals... Wait, it gave me x. That's dumb. It gave me x. I just have to differentiate to find. I don't even have to differentiate to find k. Oh wait, no, I do. So k, 2kx minus 16 over x squared equals 0, and x equals 2 over 3. 2 divided by 3 squared, and 16 divided by that is 36. 36, and then, so it's 2 times that, 2 divided by 3 times 2 is 4 over 3k. 4 over 3k equals 0. 36 times 3 divided by 4, k equals 27. Now that k equals 27, I can find y, right? Because, hello, put everything in the old equation. So it's 2 divided by 3 squared times 27. It's 12. 16 divided by 2 over 3. It's 24 plus 12. A is 36. It's 36. Yeah, okay. Okay, let's go something else. Oh my god, I forgot all about the circles. I skipped right into the circles. It's very hard questions. I don't even. Okay. I'm gonna have to study this. My brain hurts. The circle theorems. Okay, that's a segment. That's a sector. Sector is a pizza slice. Segment is just a part. I know what a tangent is. I know the radius and diameter. That's an arc and that's a chord. Okay, so you say sector is a pizza. Segment is a part. Radius. Oh, yeah, I know the radius. Arc and chord. Sector, segment, arc, and chord. Okay. Circle theorem. The angle at the center is twice the angle at the circumference. The chords to the center and the cosecant are both drawn from the ends of the same arc. Okay, so we got arc, chord. Chord is a line, pretty much. The sector is a part in an arc, and a segment is a part from a chord. The angles at the center are equal to the angles of the circumference if all the chords are drawn from the same arc. Okay, to spot this circle theorem on a diagram, find any two radii in the circle and follow them to the circumference. See if there are any lines from those points going to any other point on the circumference. It may look like the shape of an arrowhead. Here, when explaining this theorem in an exam, you must use the keywords. The angle at the center is twice the angle at the circumference, because all the chords come from the same arc. This theorem is still true when the triangle parts overlap. It is also true when you form a diamond shape. You need to compare the reflex angle at the center with the angle at the circumference. Common mistakes are to compare the wrong angles, confuse it with a different circle theorem on cyclic quadrilaterals. Questions often say to give reasons for your answer. Quote an angle fact or circle theorem for every angle you find, not just one for the answer. The center angle is twice the angle at the circumference. Okay, here's a prep question. Find the value of x in the diagram below. What? Oh my god. Hold up. 360 minus 150. I know. Wait, that means all triangles in a circle are isosceles. And if... Oh. Okay. The angle is 90. It's not 90. It is 90. Is this... I think it's 90. How's it 15? 150 minus 60 is not 15. Two x plus the angle at the center is twice the angle at the arc. Isn't that what we're talking about? 150 divided by 2 and then minus 60. Makes sense. Okay. Makes sense. That makes a lot of sense. Is this like all the points? Is that video? Just...
In this tutorial,
Okay. I'm gonna leave and come back later.